I've received a couple questions regarding troubles working problems from this particular topic despite the videos. And so I wanted to make a very quick video showing you all where the common error is if the numbers that you are getting do not match up with the correct answer, or even if you're working these examples and you are not getting the correct answer. And so in this problem that Dr. Dale worked, what we saw was that they were asking us to convert from 412 kilojoules per mole, and we converted this value in kilojoules per mole to however much energy that is, some number in joules per photon. Now the number that Dr. Dell obtained was 6.842 times 10 to the minus 19, and the units for that would be the number of joules of energy that each photon has. So you could leave it at joules if you know you're talking about per photon, or you could just write joules per photon, which is what the units are that you're left with. Now the problem is many students, when they do this conversion, even though they have it set up correctly, are not getting that value. So let me show you all very quickly where the mistake is and how we can fix it. So as you all have already seen in the previous video, this was how we approached this conversion to convert from kilojoules per mole to joules per photon. And the million-dollar question is, how should you input these values into the calculator to do this conversion? The thing that is causing the most trouble for you all is this value here, Avogadro's number. If you're not careful when you put this value into your calculator, because of the times 10 to the 23, it will mix up order of operations, and instead of getting the correct answer for this conversion, which is 6.842 times 10 to the minus 19 joules per photon, some are getting 6.842 times 10 to the 27 joules per photon. The reason this is happening is because of how you are inputting this conversion into the calculator. So how should you do this? What you need to do is ensure that when you divide by Avogadro's number here on the bottom, that you place this entire value within parentheses. So you should put it into your calculator either like this, 6.022 times 10 to the 23, close parentheses. That way you'll ensure that this times 10 to the 23 applies to this, and you do not mix any other functions. If you do not put this in parentheses, 6.022 times 10 to the 23, if you do not put it within parentheses, you will get the incorrect conversion factor, depending on how you approach the conversion. Another thing that you can do is to use this function on your calculator. Instead of typing times 10 to the 23, you can substitute the times 10 with the capital E. Some calculators may have it as capital EE. Other calculators may just have it as a capital E. For me, to get this function, I have to hit second, and then I hit the x to the minus 1, and I see there's a little EE above that. So I hit the second to access that function. And so I will write this number or type it into my calculator as 6.022. And to get around having to type the times 10, which messes up your functions if you don't use parentheses, you can use the E button and then just write 23. And so therefore, if I go forward with this conversion in this format, using Avogadro's number in this format in my calculator, I don't need parentheses, but it's always a good idea to separate all of these really big or really small values within parentheses, especially if you're typing it in scientific notation with the times 10 to some power.